Superman, da 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 da, Superman, da 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 da, are about physics by a guy named Richard Fine. Just kidding, Richard Hammond. Yeah, Hammond. Let's go ahead and talk about forces, the things that give superpowers to Superman. Let's go ahead. Physics started off with the ideas of forces, and everyone thought forces. There must be different types of forces. There's a push, there's a pull, and what other forces are there? That's what people actually originally thought. Now, what is forces anyway? Is it something you can examine in a bottle? Is it something that can glow in the dark? Is it something that fizzes if you drop it in the water? And first of all, the thing that fits in the water, that's Mentos. The thing in the glow in the dark, that's glow in the dark sticks. The third, the captured in the bottle, those are liquids or gases or solids. Forces, however, are just non-physical things. They're more like ideas. And it's a pretty simple idea too. A force has only two types, a push and a pull. And depending on what you're doing it, this side, if you're moving something like this side will be a push and this side will be a pull. Then it's just your perspective that actually makes these forces. And can you feel the force? And forget Star Wars. Forces are not things that pervades the entire universe. And there is nothing that pervades the entire universe at all. In fact, that would be impossible because the universe is expanding. And everything in the universe is constant. Sure, you can destroy and create matter with antimatter. But literally everything is just about the same. Other than the fact that we sometimes destroy it. It's actually, and the forces are just a push and a pull. Or a hit, as people say. But that's more of a push, won't you think? I mean, when a boxer's fist punches something, it's a push. That pushes the beanbag. And then sometimes it forces so much that it breaks and makes the stuffing come out. When a car moves, it's just pushing on the ground so that it moves forward. And then the ground is pushing back, so it moves forward too, instead of slipping and sliding. And sumo wrestlers, well, they're not moving at all because they weigh the same weight, so they're giving the same amount of force. Yeah. And it's the law! And I was already saying, Newton already made 3 laws of motion. The first law is an object at rest that isn't being pushed or pulled by its force must be stay still or keeps moving in a straight line at a constant speed. I just read that, but if I'm going to simplify that, it basically means this. An object stays still until something moves it, and the object keeps moving until something stops it. Usually the thing that stops it is friction. And usually the thing that moves it is an external force, not friction. Not friction, if that's what you were thinking. And then the second law is basically force equals mass times acceleration. And the third law, every action has an equal but opposite reaction. Every action has an equal but opposite reaction, meaning if I hit you with this hammer, the phone that I'm recording currently with will basically just hit back with the same amount of force. Also, it is kind of minuscule, and which is why weapons work. And let me use this with a rocket analogy. Now let's just assume that you are in a cart. And you somehow start throwing beanbags very fast behind you. And the push makes you go forward. The force there is making you forward because this is technically the third law of motion, and opposite but equal reaction. When you throw it back, the can pushes on you and you push on the can, so it makes the cart move forward. And however, it will only move very, very slow. And let's just say you somehow manage to throw enough baked bean cans behind you that you're moving at a pretty good 10 meters per second, which is pretty fast and really hard to stop. And then we're going to talk about the second force. Forces make things accelerate. It's just you just throw the beanbags faster behind you. That's just the second law, which makes you faster. The first law, an object that isn't being pushed or pulled by force either stays still, or basically something will stay still until something pushes it, and something moving will not stop until something stops it. Well, let's just say you somehow get 100 meters per second, and there's a security guard trying to stop you, and you accidentally ram into him. He moves with you. Technically, you're the force, and the guy's the object that wouldn't stay still. And that's pretty much all I have to say. And can you do physics in a bike? I would demonstrate, but it's late at night. Now, the third law of motion only applies to all this because without the third law of motion, the bike wouldn't be moving at all. the bike pushes down on the ground and the ground pushes back up, which like moves right here so that you can move forward. You set off, and now when you go downhill, like let's just say you go downhill, there's gravity that pulls you, and then you suddenly push the brakes too hard, and then you fall over. Boom, wipe out. And that's basically the first law of motion. And you keep going, and you go uphill. Now basically, you're trying to move fast. However, force equals mass times acceleration, and gravity is trying to push you down at the same time. But this will technically be the second law of motion. Gravity is more powerful than the friction with the air, so you have to pedal much harder to overcome it. And so cycling uphill is really, really hard. And now, what causes friction? Well, friction is basically the heat that you can feel when you rub your hands together. And it's basically two substances rubbing together. No substance is smooth. In fact, this smooth substance isn't that smooth at all. Not the grooves I'm talking about, the smooth part. Not even tape. The smoothest thing I can think of isn't smooth at all. They all have little bumps and bumps in it. If you magnify it enough, you'll basically see a lot of dots on it. Imagine like little tiny mountains that only Ant-Man can interact with. But only Ant-Man can interact with slightly and cannot interact without causing friction. We interact with it all the time. When we walk or when we hit stuff, the grooves there sometimes hit it, and if we slide them together, we basically create friction, which is what makes matches work. And that friction is what we need to overcome so that we can make things go faster. And for some reason, humans like going faster. And the fastest thing we've ever created, the Helio spacecraft. Now, spacecrafts are basically the only things that can leave the Earth, as long as they have enough fuel too. And eventually we'll probably only need to find maglev spacecrafts, so we'll be able to go up without needing any fuel at all. Ha 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 ha. Other than maybe fuel to keep the ship running itself, that is. It'll just keep itself up, sure, but the only thing that we need, the heaviest thing there would probably just be the anti-gravity chamber. The second heaviest would just be the generator that puts all the electricity on board. And how fast can you go? A person goes at 43 miles, 27 miles per hour. An insect goes at 35 miles per hour, the smallest one that is. A submarine goes at 46 miles per hour, and the fastest thing is space probe. The space probe is just 157,083 miles per hour. Compared to the speed limit of the universe, that is very, very slow. That's not even 1%, or that's not even 0.00001% of the speed of light. Okay, maybe it's close, but it's not at all. And then the G-force is basically the reason why astronauts get themselves stuck to their back, like get stuck to their seat when they're going up to space. Because it's a very big pull as gravity tries to push them down, and the thrust of the rockets actually make them go up. It's stronger than gravity, so it makes them go up. So there's a battle between you, the gravity, and the thrusters on you, so you get stuck on your seat. Whee! And yeah. Then we have energy. Chemical energy, potential energy, kinetic energy. I made a whole video about this in another episode, but I'm just going to re-explain all this. Chemical energy is types of energy. Potential energy is the energy that could happen. Like, when I'm dangling this down here, when it stops, now, it basically has potential energy. Like, it has potential energy because if I drop it, all that potential energy turns into kinetic energy, which is energy that's being used. Chemical energy is basically the thing that powers you. Whenever you eat food and the stuff that disintegrates it, and those disintegrated stuff turns into energy because of chemical processes, that's called chemical energy. Light energy is basically just light. Heat energy is just heat. Electrical energy is energy that we create with using electricity. Dark energy is something that we still don't understand at all. Nuclear energy is what makes the A-bomb work, and what makes nuclear plants very, very dangerous. And yeah, and how can we even measure energy? We usually use joules, but there's this very simple formula that we can use. E equals mc squared. Energy equals mass times the speed of light squared. C is just a symbol that we use to represent the speed of light. Apparently, it's a Greek or Latin term meaning light. And how can you make forces bigger? Well, usually a fulcrum will work. And basically, you can use a fulcrum to be able to make your weak hand energy into something stronger that can even cut a nut open. Or you can just use it so that you can make a very delicate grip on something. Or you can just use it as scissors too. But that's pretty much all we seem to have. We have lots of simple machines that we can use to basically destroy everything that we can think of, like the bullet. And we even use that to actually make the plane fly by using lift. And I'm not going to go in details yet. And ever since we started physics, we keep starting to understand it. And there's so many things we still don't understand about physics at all. So the next time you hear someone believing that Thor exists, or that Zeus exists, or that Yoda exists, or Yoda, then shut them up and tell them about physics. Oh yeah, and give them a Thor hammer too. See you guys soon, and until next time, Shnan out. Peace. Da 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 da.